Our first session presenter is Erin Gray, Senior Geologist. Erin will share insights from her mapping in the Kiwirrkurra region. This remote region in the Gibson Desert near the Northern Territory border is emerging as a highly prospective area for mineral exploration.
Today I would like to share with you some results from heavy mineral mapping of the Kiwirrkurra region. GSWA are working in the Kiwirrkurra region because it is a key frontier greenfields region in Western Australia. It is the area proximal to Lake Mackay and the community of Kiwirrkurra near the Western Australian Northern Territory border. The basement geology consists of the Western Australian portions of the Paleo to Meso-Proterozoic Aileron and Warumpi provinces, shown here, outlined in red, which are mostly exposed within the Northern Territory, where they have been studied more extensively. The Aileron province is separated from the Warumpi province to the south by the Central Australian suture. The basement rocks are overlain by the sedimentary Amadeus, Canning and Murraba basins, as well as younger deposits, including longitudinal aeolian sand dunes, sheetwash and lacustrine sediments. This region is considered highly prospective for mineral deposits based on the mineral systems framework. It features a cratonic margin setting that has been reactivated over geological time, regional metamorphism, and evidence of alteration and fluid mobilisation. Indeed, a recent increase in exploration activity substantiates this potential prospectivity, with notable discoveries including niobium rare earth deposits in the northern Aileron. However, the Proterozoic geology mainly considered prospective for mineral deposits is buried under multiple generations of cover. So today I want to share some insights from GSWA's heavy mineral study done on regolith samples from across the Kiwirrkurra region. This was done in collaboration with the John de Laeter Centre at Curtin University, and we analysed 42 samples from a variety of regolith landforms using automated mineralogy. So this chart shows the heavy mineral background for all samples across the area in mass percent. Unsurprisingly, there was a lot of iron oxide, ilmenite, tourmaline, titanium dioxide, and zircon. There is also a lot of an iron and aluminium bearing poorly crystalline material interpreted as a soil leaching zone mineral. Another interesting feature of this dataset is the abundance of manganilmonite, which ranges from 1 to 15%. The published literature on manganilmonite is sparse and indicates that it is relatively rare. However, a 1988 study by Cassidy et al. Found manganilmonite to be widespread across the Archean, mafic and ultramafic greenstone belts in the Yilgarn, where it is petrogenetically associated with regional metamorphism. So the association between manganilmonite and metamorphism supports observations of widespread regional metamorphism across the Kiwirrkurra region. So this is a breakdown showing the variations of the main minerals identified by TEMA mapping. As you can see, almost all samples contained the same minerals, only varying in relative amounts. There was no apparent systematic relationship between the overall heavy mineral distribution and the regolith type. This is possibly not surprising given the abundance of quartzo-feldspathic sedimentary rocks in the area, which do not have a strong primary mineralogical signature to impart to derivative sediments. Any signature is likely to be more cryptic in nature, for example, detrital zircon ages or mineral chemistry. Two samples are the exception. These are significantly elevated in amphibole, and these were taken from areas quite close to outcropping metasedimentary and metaigneous volcanic rocks, and the heavy minerals are in part likely locally derived. So most samples contained potential indicator minerals. Of particular interest are those that are low in abundance, often comprising only up to 20 grains of a mineral in a sample. These can provide evidence for different mineralising systems and vector towards ore deposits. Of the minerals we identified, most can be considered as being associated with base metals, pegmatites and carbonatites. There are a lot of colours on this slide, but what I want to demonstrate is the variety of indicator minerals observed in the Kiwirrkurra samples. There are a lot of really interesting aspects of this dataset, but in the interest of time, I want to focus in on the northern Aileron to show how the indicator minerals can be used in conjunction with GSWA's fine and ultra-fine soil geochemistry to put together a picture of the mineralisation. The northern Aileron is one of the areas that has seen increased exploration in recent years, with niobium rare earth deposit mineralisation associated with extensive carbonatites. The area is dominated by granitic lithologies and metasedimentary rocks of the Aileron province. There are also a variety of regolith landforms across the area. If we take a closer look at the soil geochemistry, in the westernmost part we can see anomalous tin in the ultrafine fraction, the hollow black circles, and in the fine fractions, the solid blue circles. These samples overlie the dwarf well granite. Tin is also anomalous in the ultrafine further east. 3 of the samples in the dwarf well granite area contain tin-bearing indicator minerals, a polymetallic tin tungsten lead aggregate, and cassiterite. One of these dwarf well granite samples, 191261, also contains cuprite. So let's have a look at the copper. Well, we see elevated copper values in both the ultrafine and the fine geochemistry in both the southwest and northeast. A sample in the northeast also contains cuprite along with tantalite, but interestingly, all the soil geochemistry is below detection limits, or in the case of the ultrafine, very low in tantalum. The ultrafine and fine fraction geochemistry from the northern Aileron shows anomalism in a host of other elements, including lead, manganese, zinc, and some of the rare earth elements. Together, these data sets, alongside the exploration history of the area, are helping to evolve our understanding of the mineralisation. In addition to the emerging carbonatite story, there is a little more evidence supporting base metal mineralisation, so in this case copper, and mineralisation associated with evolved silica-rich and or fluid-rich magmas, leading to crystallisation of minerals such as tantalite and tin tungsten lead aggregate. So to zoom back out and briefly look at the whole area, while I focused on the northern Aileron, we found some really interesting minerals in the southern half of the map, including struverite, which is a tantalum and iron variety of rutile, ilmenorutile, which is a niobium rutile, columbite, spinel, and a host of zinc-bearing minerals, such as echondrusite, garnite, and zincostaurolite. Echondrusite and garnite are higher in abundance than we expected, and this observation was also made in the heavy mineral map of Australia by de Laeter et al. In 2023, suggesting that perhaps these minerals aren't as rare as we previously thought. The combination of 2 or more of these in a sample is probably a better indication of mineralisation than one by itself. So to summarise, coupled with the pre-existing fine fraction regolith geochemistry and the recently released ultrafine soil geochemistry, the heavy mineral dataset adds another layer of information to help inform decision-making in exploration. Together they provide clues about the styles of mineralisation and demonstrate the value of automated mineralogy, as can be seen in this case study of the Northern Aileron, highlighting further evidence for copper prospectivity and identifying previously unrecognised potential for tin mineralisation, possibly associated with pegmatites. The heavy mineral dataset and an associated record, along with a heavy mineral atlas, is coming soon and will be accessible via the DMPE Data and Software Centre and on eBookshop. You can also access the ultrafine geochemistry record and dataset, along with a recent record on carbonatites and lampriphies in the Northern Aileron from our eBookshop.